Welcome to the training module on dial indicators. Dial indicators are commonly used to measure runout. There's axial runout and radial runout. Runout is the untrue movement or motion of a rotating object. It is also used to measure axial clearance, which is the axial free movement of an object. This animation shows axial runout on a ring gear. The gear is wobbling, therefore the dial is bouncing back and forth, showing the amount of runout on the ring gear. This example shows how we can measure axial free movement of a gear. The amount of movement the gear moves back and forth between the thrust bushings is measured on the dial indicator. This is an example of a 1-inch linear dial indicator. On the far right we have the tip that screws to the plunger. Then you have the body of the dial indicator and the dial itself, which has a scale on it and the needle that moves. On the top left is the scale lock. Loosening the scale lock allows you to turn the outer scale for calibration. In addition, we have the range. This number here, it tells us the range of the dial indicator. This one is a 0 to 1 inch range, and the units of measure or accuracy. Here, we are measuring in inches down to 1/1000th of an inch. And finally, the revolution counter. The revolution counter counts how many times the dial has actually gone around. This is a 30,000th of an inch dovetail dial indicator. Here we can see that we have the mounting locations, the body, the plunger, the mounting adapters, and the dial itself, and the units of measure. Reading the 1-inch dial indicator. The large scale number in black are from 0 to 100,000ths of an inch. The large scale numbers in red range from 0 to plus 50,000ths of an inch and from 0 to minus 50,000ths of an inch. The scale in the middle records the number of revolutions. This recorded one full revolution of the big scale for every number on the small scale. The number 1/1000th of an inch in the middle indicates that each large scale line is equal to 1/1000th of an inch. When measuring a value that is greater than one full revolution on the large scale, we need to look at the small scale as well, because that counts the number of turns. In this example, you can see that the small scale has actually passed the 4. This indicates the large scale has gone around 4 times, and that equals 400,000ths of an inch. Now take a look at the outer scale. The black number reads 20,000ths of an inch. If we add both of these numbers together, we come up with the value of 420,000ths of an inch. Can you tell me what this dial reads? Look closely at the small scale. Notice that it's almost at 400,000ths of an inch, but not quite. Now look at the large scale. Add these two values together. You should come up with 397,000ths of an inch. Now let's look at reading the dovetail. This dovetail reads a maximum of 30,000ths of an inch. Therefore, we use it to measure small measurements. We use it where a linear plunger won't work. Take a close look. Each line measures 5/10,000ths of an inch, or also known as 1/2 of 1/1000th of an inch. Every 2 lines equals 1/1000th of an inch. When I read the dovetail, I typically count by halves. For example, my first measurement is going to be 1/2 of 1/1000th of an inch. Then the next line is going to be 1/1000th of an inch. Then 1.5 thousandths of an inch. Then 2 thousandths of an inch. 2.5 thousandths. And finally 3 thousandths of an inch where my pointer is lined up to. Take a look at this reading. Here it is showing 12.5 thousandths of an inch, or it could be stated as 125 10,000ths of an inch. It would be written as 0.0125, and the close quote mark using the close quote symbol indicates inches. Dial indicators rarely measure static value. Often the movement is less than 100,000ths of an inch. Therefore, we don't need to look at the small gauge because it is less than one full revolution, and we measure total needle movement. That means we add the negative movement to the positive movement to get the total movement. Notice the needle moves from plus 5 thousandths of an inch to minus 90 thousandths of an inch. The total needle movement is 15 thousandths of an inch. The needle moves 10 thousandths of an inch to the negative side, then 5 thousandths of an inch to the positive side, for a total of 15 thousandths of an inch. Here on the dovetail, we're watching the movement of the needle. The movement is from 4.5 thousandths of an inch on the minus side to 5.5 thousandths of an inch on the minus side, for a total movement of 1/1000th of an inch. What is the total amount of movement on this dial as it swings back and forth? If you figured it was 42 thousandths of an inch, you are correct. How much total movement is shown here on the dovetail? Did you figure 6.5 thousandths of an inch? If so, you are correct.